Well, good afternoon. At least it is for me. I have a few moments this afternoon to do something I've been wanting to do for a while, and that is to put together a few demonstrational videos for T-Splines or SolidWorks, otherwise known as tsElements, and show how this can be a great workflow for designers, engineers who want to create complex shapes but struggle doing that in SolidWorks, and show how this can be used to create complex shapes and then have them be editable in SolidWorks. Now, 3D modeling isn't really for everyone and for every shape, but there are some shapes that are very difficult to design and execute in SolidWorks and are better suited for a subdivisional type of modeling workflow. So, just to introduce myself, I'm Mark Biasotti, and I am a product specialist with SolidWorks here in Concord, Massachusetts, and I want to spend the next few minutes showing you this exciting new workflow. Okay, so here you can see I have Rhino, a pretty standard default setup, but with my T-Spline toolbars up here at the top so I can get to them quickly. So the way we're going to start this faucet design is to create a simple mesh primitive. And I'll start in the top plane and I'll make a 3-inch diameter mesh primitive. It's 8-sided, and for purposes I'll explain in a moment, I'm going to grab this and rotate it about that midpoint up, so I have this face right here aligning parallel with my x-axis. Okay, so let's go ahead and just go right into T-Splines by converting this guy to a T-Splines and then showing it in smooth mode. So now we have that mesh toggled into a T-Spline and showing smooth. The next thing I want to do is make this a more of a realistic looking cylinder with hard edges at the top and bottom. And T-Splines by default, when they're created, are created as a completely smooth object. But fortunately we have a crease command to make hard edges back. So I'm going to go ahead and grab these edges and do the same with these edges. And go ahead and apply a hard crease to the top and bottom. And so now I'm ready to go in and do a little bit of manipulation to my T-Spline to get the features I want. So what I'm going to do here is take this front face and start pulling it out to make my faucet design. So enabling that face, I can just start pulling on the model and pulling it out a bit, pulling it up a bit, and then in my top view I can turn on vertice selection and then scale that out, so just get a little bit wider, more rounder front end to the bottom of my, or the spout area of my faucet. Okay, so at this point I want to add another hard crease to this design. And so I'm just going to pick these front edges and apply a crease to those. And you've seen designs like this from Cole or American Standard. It's kind of a 90s design. And so I've got pretty much what I need, but now I just need to do a bit of adjustment. One of the things here is that this edge here, if I get the whole loop by double clicking on it, at least I should be able to get the whole loop. Let's do that again. Let's drop out of our edit mode. There we go. I want to take that whole thing and then move it up by a certain value. Like, yay. And then I see I'm getting too much of a sharp transition here in the front, so I'll just pull that out again by just grabbing these verts like so. And then I also want to pull these up too, so let's go ahead and grab those and pull those up like so. That's more like what I need. But you know, the whole thing's a little high now, so I can just grab all of those and pull them down. There we go. Do a bit more of adjustment here. Okay, that's looking good. And then let's go ahead and grab this top edge again and pull it down. There we go, like so. Okay, that's looking good now. So go back to our 3/4 view. We've got the basis for the lower end of our faucet design. So now what I'm going to do is create a new layer, call this handle, and go ahead and make it active. And on it, I'll start a new T-spline. So you can create multiple T-splines and bring those multiple T-splines into SolidWorks. So let's go ahead and create a spherical mesh primitive on the top here. And let's go ahead and convert that to a T-spline. And there we've got it. So we can take that object now and we can scale it. So let's go ahead and take that and let's just pull on it to make it just to match. Oops, I grabbed everything and I shouldn't have done that. Okay, let's just grab this and then scale it. There we go. Okay, and let's get that back into a smooth mode. Maybe there we go. Okay, back where we need to be. So looks like that just needs to be scaled just a bit more. That's good. Okay. So now let's go ahead and make our handle shape coming out of the front of this spout area. And I'm going to just take and grab on this face here and pull it out. And pull it up a bit to match our faucet area. And then just hide this for a moment. Let's go ahead and grab the verts in front here, and let's go ahead and scale those along the x-axis. Make it a little broader up front. Okay, and then I want to go ahead and grab all these top edges and put a crease on them. So I'm going to crease those. And then I'll grab my vertices here for this dome and pull that down a bit, or I can scale it actually by this axis and then pull it down like yay. Okay, so one thing I noticed here is if I turn on my layer for my bottom is that we've got a mismatch between these two here, and so I think what I can do as a strategy is grab these verts and pull them in a bit, or what I can do is create a new crease here to tighten this area up. So I'm going to add an edge to the model, and using this edge I'm going to add a crease right in here, but I need to actually grab all of that let's do that in our 3/4 view here. There we go. And now we can go in and add an edge right in here to the model. There we go. And now you can see that we've gotten a sharper transition here because we've added new topology to the sub D. So let's go ahead and just turn that on again. We can see a little bit better match. And now with that in place, I can just grab these verts up front here and maybe just scale those in from the top. So let's do that. Okay. There we go. Let's maybe just pull them back a bit. And then to get a tighter radius here, we can actually just grab these verts and pull them up to here. And so now we have a pretty good match on that bottom. I think to get these transitions here to work a little bit better, that we'll just scale those back a bit. Okay. Okay, so there we got it. So of course we could do a lot more, but with the time I have to present this, I'll just kind of move ahead. So now we've got a basis for design. So let's get over to SolidWorks and see what we can do there. So first I'm going to save this out as a faucet design by today's date and just put it over in my temp directory. And we saved that. So let's bring up SolidWorks and open up that T-Spline file. So here you can see we can import TSM files or OBJ files. I'm going to pick this, go to my temp directory, and then go and open up that T-Spline file. So you know what? I think I didn't save it as TSM out of Rhino. I saved it as a Rhino file. So let's save as a TSM file. And you can't see it here because this is too high, but let's go down right here to our temp. Okay, that looks good. Okay, so let's jump over to SolidWorks and open up those TSM files. And let's make sure that comes in an inch. Okay, so one kind of byproduct of doing a crease in a T-spline in Rhino is that you get this kind of result in SolidWorks. Now this is completely planar, but it's segmented to get the sub D solution, and I could delete all these faces and using my delete face command and then build a planar surface there pretty easily. But alternately, we could also just remove that face in Rhino. And so let's do this. Let's just pick these faces and hit our delete key. And let's do the same for the bottom faces. And now let's go ahead and just save again this T-Spline file. Let's go back to SolidWorks and open that up again. I don't know if you can see this, but here's the drop down for TSM file type. Okay, there you have it. We have the T-Spline surface body now, but without these faces. So while we're here, let's just go ahead and load the handle also. And let's make sure it comes into the same current file in inches. There we go. So let's go ahead and hide the handle for the time being, and let's just make this solid again. We can do that really easily again, as I said, by using planar face, selecting open loop, doing the same on the bottom here, open loop. Okay, and then going and knitting this up using these faces and making solid. There you go. So you can see that we have a solid model, or two solid bodies, handle and the lower part. But you know what? I see something here I don't like, and that is that I must have pulled something in Rhino here to make this asymmetrical from left to right side. So I'm just going to quickly cut this solid using this face. And let's see, we want actually this side here. So picking this body, we'll keep that side, then we'll mirror it back. Feature mirror using this body across the right plane, merging it, and now we've got something that's symmetrical. And so now at this point, let's go ahead and just start shelling. So we're going to use these as a remove faces, give it a 1/10 of an inch wall, and now we've got a shell. Now let's go further and use SolidWorks for the things that we want to do here, and that is to create some details. So here I'm going to create a spout detail, revolve this shape, and let's give it some kind of positional dimensions from top plane, front plane, give it a distance here, and a revolve of 7.5. Okay, let's go ahead and just revolve that using this as our axis, and merged right into our lower faucet design. You know what? I think it's a little big and a little too far back, so let's do this. Let's do some adjustments here. Let's bring it out a bit. Forward a bit, and reduce its diameter a bit. Okay, I think that looks good. Now, since you can't really have sharp edges in castings like this, let's put a variable fillet right here. So we'll go ahead and use a variable fillet, picking these edges, turning off tangent propagation, making the beginning and ends 0, and the forward 1/10 of an inch. And then let's also put a nice fillet transition here, but since the angle of incidence changes quite a bit between these two faces, I'm going to use face to face, and then I'm going to make constant width. That way we get a nicer transition between the two. Let's go ahead and include that there. Let's bring that up to about 0.3. And now we've got a really nice transition between the spout area. And let's go back and focus our attention on the handle. And let's go ahead and cut, since you know what, at this point I'm just interested in making a rendering basically of this, and we'll do more detail later in our design. I'm just going to actually just cut off part of this top handle, even though the ball area would be included as part of the actual mechanism. So I'll just make a simple cut, removing this side of the handle, and then I'll just do a move face on this little top face here, if I can get to it. There we go. Now let's go to the right view, and pull that back. So we have a nice little appearance gap. There we go. So we can add a constant fillet up here too. Try to do that. Too big a fillet. So I want to go down to something like 0.5. Should be nicer. And pretty much have my faucet design. So what if something needs to change here, given some engineering parameters? We can do that with our T-Spline features that are directly in here. But one other thing I want to do here, just use the power of SolidWorks. That shell, we did that this revolve feature and the fillet as after the shell. So let's go ahead and include this in the shell feature. So I'm going to just drop down the shell to after this, and then as part of the shell definition, we'll just include this face as part of the remove. And also I could have included the variable fillet too, but for time's sake here we don't. So now what's interesting is that if we want to do any adjustments on this, we can do that by editing one or both of our T-Spline surfaces. So let's say for instance I actually wanted to do some adjustment here, and I'm going to pick our T-Spline here, and in my right view say I want to actually kind of pull down this area, bring it in a little bit more. I need more material at the end here. And let's say from a top view, I actually want to take these points here and I want to kind of grow those out. And I'm holding down my shift key and I get that symmetrical behavior. And so now when I rebuild, I should get everything back. I'm on a debug version, that's why I get that. And sure enough, everything is good to go. Now a couple other things to point out is when I'm in editing a T-Spline here in SolidWorks, I can actually see it in zebra, and as I pull things up, I actually get my zebras to show also, if that's important to you, and see what's going on. And alternately, I can also show box mode. So this is where the original T-Spline started, from a polygonal mesh, and so I can, if it's easier for you to visualize, you can actually put it into this mode and pull on things using that. So if that suits your fancy, you can do that also. So, and then you can just turn off box mode, rebuild, and you get everything. So that's pretty much it for the time I have here, and show you how that workflow can work. So there you have it, tsElements for SolidWorks and T-Splines for Rhino. If you want to find out more about these products, you can visit the T-Splines website shown on the screen here, or visit Rhino at www.rhino3d.com. I'm hoping to produce a few more of these videos in the coming week or two, and I'll be sure to cover some of the more of the features that both these products have to offer. Have a good day.